Alright, so we're going to look at applications of Venn diagrams and then table cases. Alright, so first, we're going to do applications of two set Venns. And remember I said we weren't going to really do much with Venn diagrams. And these two applications that I'm going to go over, you could solve without the Venn diagram, and I will use the formulas along with the Venn. It's up to you which method you prefer. If you're just a straight formula person, use the formulas. If you like the Venn, and again, I encourage you to use the Venn because I think it's just a great aid or tool. And I will do them hand in hand. I'll do them together. What's interesting, or what we have to talk about in terms of the applications, is most of the time in applications, when we're giving you a probability of something, we talk about it in terms of a percent, and that's how a lot of applications are set up. So it's important that you understand how a percent and a probability work in tandem. Alright, so we should be able to convert between percents, decimals, and fractions. You should be able to do that. They're all the same thing. Right? The percent talks about out of 100%. The probability is out of 1. It's a fraction out of 1, or a decimal out of 1. Right, so just sort of reiterate that, because these are going to be applications where we will have percents and we have to convert to decimals or percents themselves. 75% of the students have an A or B in the class. Right? Again, that's usually how we talk about it. 75% of the class have an A or B. Alright, so what's the probability if I randomly select the student, they have an A or a B from the class? So probability of an A or B. Well, probabilities are always numbers between 0 and 1. So they're either decimals or fractions between 0 and 1. So we have to convert the 75% to the decimal, which means we move the decimal place over twice. Or you could think about it as dividing it by 100. Right, 75% out of 100%. So 75% can be converted where you take 75% out of 100%, which is the fraction 75 out of 100, which can be written as the decimal 0.75. Now, we usually don't go through this, but this is the process behind it. We usually just go to move the decimal over twice. But if it's a probability, it's got to be written as a decimal. If it's a percent, it's got to be written as a percent. So working the other way around, if I have my probability is 75 and I want to convert to a percent, well, we multiply it by 100%. And that gives me my 75%. Right? And we do need to be able to convert back and forth between decimals, fractions, and percents. Alright, the first application where I'll use a two-set Venn diagram, which again, they can go tandem with the formulas. So use either the formulas or the Venn, or, like I said, I'm going to work them together. So suppose we took a survey of married couples. Alright, we didn't tell you how many married, so it could be a big survey, small survey. It didn't say. I could have surveyed 10 people, 100 people, 1,000 people, 5 people. But we tallied it up and we took the numbers down, and we got that 72% of the couples said the husbands were happy. 65% of the couples, the wives responded they were happy. 52% of the couples responded both of them were happy. So out of how many, which I don't know, we've got these percentages where we've classified people as our husbands being happy, wives being happy, or both being happy. Alright, so couples selected at random. What's the probability of that? And we'll get to probability. So it means I need to go down here. We'll do probabilities, and we'll do that in a second. So first, I'm going to set up a Venn diagram. Alright, and so what's interesting about the Venn diagram, remember, the Venn represents all of the people. Well, I don't know how many people were surveyed, but I know that all of the people are represented by 100%. Whether I surveyed 10 couples or 100, or 50 or 1,000, 100% of those should be represented in my Venn diagram. We grouped them into two groups. Husbands were happy, wives were happy. So I'm going to do HH for happy husbands, HW. So this is the circle that represents happy husbands. This is the circle that represents happy wives. This wedge in the middle is both of them are happy, which we know that. 52% of the 100 lands in the middle wedge, right? 52% of the couples surveyed, so they are both happy. So we've taken into account a little over 50%, 52%. Meaning the rest of these areas will be filled by the 48% left over, where they answered one or the other, or neither were happy. And now I've got to figure out my other spots. So now I'm going to use the fact that I know that this circle is my happy husbands. Well, that circle should represent 72% of the 100% of the people in the survey. I've already counted 52% of them where the wives were also happy, so what's left over would be only the husbands were happy, the wives were not. So I take my 72, I subtract my 52, and that's going to leave me with 20% of those surveyed. Husbands were happy, wives weren't. And then I do the same thing with the wives. 65% of the wives said they were happy. We already counted 52% of them where the husbands were happy. And so I take my 52, subtract it away from my 65, and that's going to leave me with 13%. The wives were happy, but the husbands were not. I'm not done yet, right? I've still got the outside area where both people responded that they were unhappy. Well, what you do is you take 20, 52, 13, add them up, subtract them from 100, and that'll leave me with the percent where both of them marked off they were unhappy. And so if you add them up, that gives me 55, 20, so 85, so 15%. Alright, so 15% of the couples surveyed, both of them marked they were unhappy. Again, this is just a way to organize the written description of what the survey told me. Right now, we should answer the questions, and keep in mind, I want them as probabilities, so I'll have to convert my percents to decimals. Alright, so the first one is asking for the probability that the wife is not happy. Alright, so we have unhappy wives. Excuse me, we're outside of the happy wife circle, which would be the 20% where the husbands are happy and the 15% where the husbands aren't happy. And so we'd add those together. That would be 35%, which is written as a decimal, would be a probability of 0.35. So 35%, the wives are not happy. Or you could use the complement, right? The problem told us that, so you could use the complement formula. The problem told us that 65% of the wives responded they were happy, which would be a probability of 0.65, and you could have taken 1 minus the 0.65 as the complement, and that would give you the 35 as well. Alright, so you could have used the formula. Alright, the probability at least one person is happy in the marriage, so that would be the probability the husband is happy, or the wife is happy, or both are happy, right? It's all inclusive. Which you could use the formula. You could add up the happy wives plus the happy husbands minus the overlap, or using the Venn diagram, we could just add these numbers up. So again, you could use the formulas. You'd have to do probability of happy husbands plus probability of happy wives minus probability happy husbands and happy wives, which again is fine. Or with the Venn, you could just add up these three cases, which adds up to 85%, which as a decimal is 0.85. Either way, it should get you to the right answer. Right? Neither person is happy. Well, that's that outside area. Right? Probability that the husband's not happy and the wife is not happy. Well, that's that 15%. Which would be the complement to this set. At least one of them is happy. Neither of them is happy, so you could take your 85%, subtract it from 1, or use the Venn. Right? Either way is fine. So 15% from the Venn comes out to the decimal 0.15. Right, the wife is happy, but the husband is not, so probability we have a happy wife, but the husband is not happy. Right, this one really is easiest to do with the Venn. So we've got happy wives. Oops, I put happy wives and unhappy wives. It should have been unhappy husbands, right? Happy wives, unhappy husbands. Well, that's this 13%, right? I'm in the happy wife circle, but I'm not in the happy husband circle. And really that one, the easiest way is to draw the Venn. So that was 13%, so writing as a decimal is 0.13. All right, the second example of an application where we use a Venn or formulas. This one's a little tougher. The Venn setup is a little tougher. Our professor has collected data, right, on his students who attend his courses. Right? We don't know how many students, so it could be a class of 10, could be a class of 50, could be a class of 100, could be a class of 300. Right? We don't know, but we know what percent they land in each of the categories. Right? The two categories he's looking at would be the students attend regularly and they pass in class. 72% of the students attended regularly, 65% passed the class and attend regularly, 17% did not pass the class. Find the following. Right. And these are going to be percent, so I don't have to convert. So I'm going to leave this. So this would be 100% of the class, right? 100% of the students, however many there are, we don't know. We have two circles we're looking at. We're attending regularly, and were passing the class. All right, we know what percent did both. 65% land in this middle wedge where they did both of those. So I've already counted 65% of the class, which means there's only 35% left over to fill out the rest of this picture. 65% attended regularly and passed the class. 72% of them attended regularly, which would be this entire circle. We've already counted 65%, so I take my 65, subtract away from my 72, and that will leave me 7% of the class. Attended regularly, but they did not pass. They failed. The last piece of information they gave me was not the passing circle, but those who did not land in the passing circle. 17% did not pass, so 17% land outside of the passing circle. And there are two areas outside of the passing circle. There's the 7% who did not pass but attended regularly, which leaves this outside area would be 10%, right? If this has to add up to 17, right? 17 didn't pass, 7 of it left here. 10 did not pass and did not attend regularly. All right, so I'm now ready to finish filling out my passing circle. I have to take my 65 and my 17%, subtract it away from 100, and that'll leave me with the percent of students who didn't attend regularly but still passed the class. So if I add those up, subtract from 100, that leaves me with 18%. So 18% passed but did not attend regularly. All right, there's my Venn diagram that I'm going to use, and I'm going to answer the following questions using that, or with I could also use, sometimes it's helpful to also use formulas, so I'll kind of talk you through both ways. All right, what percent passed the class? All right, so again, we're doing a percent pass the class. So I'm just going to write the percent, since I'm not asking for probability, I'm just going to figure out the percent. Well, if they passed the class, that would be this group, and you can either add this together, or we know 17% didn't pass the class, so I take 17% away from 100, and so that means 83% passed the class. What percent, so still percents, what percent passed the class and did not attend regularly? So they passed the class, but they didn't show up to attend attendance regularly. Well, that's that last one we found, right? This 18%, they passed the class, but did not attend regularly, so 18%. All right, what percent did not pass and did not attend regularly? Well, that would be the outside area, right? They're not passing and they're not attending regularly. That's this 10% here. Not passing and not attending regularly. Alright, the or, I've got it written big here because the or is always one you want to be careful of. Alright, so probability. They did not pass, so they're outside the passing circle. Or they did not attend regularly, which if we're setting up the formula, that would be probability they did not pass plus the probability they did not attend regularly minus the probability of both those things, right, which would be this 10%, right? Not attending regularly and not passing the class. And so you could use the formula, or you could figure it out without the formula. So see if we can't figure it out without the formula first, and then I will also set it up with the formula. Alright, so they have to pass the class, or they cannot attend regularly. Alright, one or the other, and I don't want to do any overlap. So they're not passing the class, which would be this 10% and this 18%, right? That's the group that did not pass, would be the 7% and this 10%, sorry. Did not pass would be the 7% to the 10%. Or did not attend regularly. Well, not attending regularly would be this 18% and this 10%. But I don't want to count this 10% again because I already counted it. And so basically, there would be everybody but the 65% in the middle. That would be the 7%, the 10%, and the 18%. So 35% of the students either failed, which would be 17%, or didn't pass the class, which would be this percent here. And I don't want to count 10% twice. Alright, so 35% is the answer using the venns. Now, in this case, using the venns could be tough. So I'm going to also fill it out with the formula just so that you can see how it works with the formula. Alright, so with the formula, did not pass, well that was 17% did not pass. Did not attend regularly, so not regular attenders, was 28%, and both of them were the 10%. I'll show you where I got those, alright? So not passing was the 17%. Not attending regularly was this 18 and this 10, right? 28%. And then I have to subtract away 10% because that landed in both groups, right? 10% were part of those who did not pass and did not attend regularly. So 17% plus 28% minus the 10% is 35%. All right, and even though I wrote probabilities down here, I left them as percent. 17%, as long as you're consistent when you're adding and subtracting. So if you write them as percents, write them all as percents. Or write them all as decimals, or write them all as fractions, alright? Right? You can only add and subtract like things. And so since I was wanting the answer in a percent, I left them as percent. So 17%, 18% minus the 10% overlap leaves me with 35%. Alright, the last one is another or. Alright, so what percent passed or attended regularly? Well, this one would be easier to do with the Venn diagram, right? That would be everybody who lands in my two circles, right? They attended regularly or they passed the class, so it's everybody here. Which if I add that up, or use the complement, I don't want these 10%, that would be 90% of the class either passed or attended regularly. And that one's easier probably again to do with the Venn. You could set it up with a formula. You would do probability they passed plus probability they attended regularly minus the probability they passed and attended regularly, and you should come up with the same answer. Alright, so that finishes up Venn applications where you can use the Venn, the formulas, and sometimes it's good to use them hand in hand together. Now the last example from the 7-3 notes is a table case, so I'm going to do the table case all by itself in the last video. Alright, so that finishes up percents and applications where I can set up a simple Venn diagram, and that would be the only outcomes where we'd use a simple Venn diagram. Alright, so I'm going to stop there.